This is Algebra 1 class, and today we're going to be looking at the zero product rule in section 9.4 in our text. The zero product rule is when two numbers are multiplied and the product is zero. Then one of the factors has to be zero. For example, 3 times 0 equals 0. The two factors 3 and 0, one of them is 0. And again, 0 times negative 87 is 0. The two factors 0 and negative 87. Even with three factors, it's the same idea. 0 times 12 times 2/3 equals 0. Our three factors 0, 12, and 2/3, one of them is 0. We can even have algebraic expressions as one of the factors. Here we have 0 times the quantity x minus 1 is equal to 0. Again, one of the factors is 0, the other one is a polynomial expression. In general then, if a times b is equal to 0, then either the a is 0 or the b is 0. Let's take a look at a couple of examples. In this case, we want to solve for x. We have in example 1, 5 times x equals 0. The two factors are 5 and x. One of those two factors has to be equal to 0. Well, 5 is not 0, so that leaves us with the factor x having to equal 0. Let's do that again. On number 2, we have negative 2043 multiplied by x equals 0. The two factors are negative 2043 and x. One of these factors has to be equal to 0. It can't be negative 2043, so that means x has to be 0. Factors can be polynomials or monomials. In these examples, we want to just name the factors. So in this case, we have two factors. Two binomials are multiplied together. The first factor is x minus 1, and the second factor is 2x plus 3. Again, in number 4, we have two binomials multiplied together. The two factors are the binomials 5x plus 3 and the binomial x plus 10. In number 5, we have a monomial multiplied by a binomial. So the two factors are the monomial 3x, which can also be broken down into the number 3 and the variable x. And finally, we have the binomial x plus 4. So in this case, we actually have three factors. We have the number 3, the monomial expression x, and the binomial x plus 4. To solve an equation, all we have to do is set each one of our factors equal to 0 and solve. Because when we're looking at the zero product rule, one of the two factors multiplied together has to be equal to 0. So let's do that. In number 6, we have two binomial factors. The first one is the binomial x plus 1, and we're going to set it equal to 0, and we're going to solve it. So subtracting 1 from both sides gives us x equals negative 1. The second binomial is 2x minus 5. Set it equal to 0. Solving for x, we get x is equal to 5/2 or 2.5. So since we have two factors, we end up with two solutions. Let's take a look at number 7. Here we have the monomial 3x. If we set it equal to 0, that breaks into the two factors like we did in example number 1. Our two factors in example 1 were 5 and x. 5 couldn't be 0, so x was 0. The same thing is happening here. We have 3 times x equal to 0. 3 can't be 0. Here's our two factors. 3 can't be 0, so our only one here is x is 0. Another way to look at that is if we take the equation 3x equal to 0 and we divide both sides by 3, we get x equals 0. Either way we do it, from the factor 3x equal to 0, we get the solution x equal to 0. Now our second factor in this equation is the binomial x plus 5. So x plus 5 equal to 0. That gives us x equal to negative 5. In example 8, we have 3 factors. Let's set each one equal to 0 and solve. So our first factor is x equal to 0. That's already solved. Our second factor, 2x plus 8, set that equal to 0 and solve, subtracting 8 from both sides and dividing by 2. X is negative 4. For our third factor, we have x minus 2. If we set that equal to 0, we have x minus 2 equal to 0. Solving by adding 2 to both sides gives us x equals 2. So we have 3 solutions because we had 3 factors. Our 3 solutions are x equals 0, or x equals negative 4, or x equals 2. When equations aren't already factored, we need to get them in factored form. In other words, we need to undo the distributive property. Let's take a look to see how factoring works. In these 2 examples, we want to find the greatest common factor and then factor each expression. A greatest common factor is the largest combination of numbers and variables that will divide into each term. So as I look at 12x and 42, when I look at the numbered parts, the 12 and the 42, the greatest common factor, the GCF, is 6. 6 divides into 12 and 42. When I look at the variables x and y, they're different, so they don't have a common factor. So our greatest common factor of these 2 terms is just 6. And we rewrite it using the distributive property, or we call it factoring, by dividing 6 from each of these 2 terms. So 12x divided by 6 would leave us with 2x. 42y divided by 6 leaves us with 7y. Let's check. Let's go ahead and mentally check the distributive property. 6 times 2x would be 12x. 6 times 7y would be 42y. So the process of factoring out a common factor is basically reversing the distributive property. Let's look at example number 10. In this part, we have the numbers, the coefficients 4 and 24. So when I look at 4 and 24, the greatest common factor is 4. 4 divides into 4, 4 divides into 24. Now when I look at the variable parts, I have x to the 4th and x cubed. When we have an exponent, this means I have 4 factors of x. This one means 3 factors of x. So they have 3 factors of x, or x cubed, in common. So our greatest common factor is going to be 4x cubed. So let's use our factoring, our reversal of the distributive property, to take our common factor and divide it out. So 4x cubed is going to be out in front of our parentheses. Now let's divide. 4x to the 4th divided by 4x cubed leaves us with x to the 1st. And 24x cubed divided by 4x cubed leaves us with just 6. Let's check. Let's do mentally the distributive property. 4x cubed times x to the 1st is 4x to the 4th. 4x cubed times 6 is 24x cubed. Now let's use that to solve, or to factor. We're going to factor some more common factors. Here we have 7y squared plus 7y. Our greatest common factor of the 14 and the 7 is 7, because 7 goes into both 14 and 7. In our variables, we have 2 factors of y and 1 factor of y, so we have 1 factor of y in common. So we're going to write 7y multiplied by the quantity. 14y squared divided by 7y is 2y. 7y divided by 7y is 1. Okay, now this is the tricky one. Some of you guys are going to want to leave that out because these two are the same, but we're doing division. A number divided by itself is 1. Okay, in number 12, we have 3 terms, and so we're going to look for the greatest common factor of all 3 terms. When we look at our numbers 14, 8, and 6, our greatest common factor, number that divides into 14, 8, and 6, is 2. Then we look at our variable m. We have 3 factors of m, 2 factors of m, and 1 factor of m. So our common factor is 1 factor of m. So writing 2m factored out, and we're going to divide to find our terms inside the parentheses. So 14m cubed divided by 2m is 7m squared. 8m squared divided by 2m is 4m. And negative 6m divided by 2m is negative 3. Let's check and make sure that we have it right. Let's mentally check the distributive property. 2m times 7m squared is 14m cubed. 2m times 4m is 8m squared. And 2m times negative 3 is negative 6m. 2 more examples, and then we'll do solving some equations. In 4xy minus 2y squared, notice in the first term I actually have 2 variables. Okay, so let's see how that works. Starting with our coefficients, our 4 and our 2, our greatest common factor of 4 and 2 is 2. For our variables, this one has a factor of x, but our second term does not have a factor of x, so they don't have a factor of x in common. Then we go to the y. We have 1 factor of y and 2 factors of y, so they have 1 factor of y in common. Writing our greatest common factor outside our parentheses. 4xy divided by 2y is 2x, and negative 2y squared divided by 2y is negative y. Let's check. 2y times 2x is 4xy. 2y times negative y is negative 2y squared. One more example. Our greatest common factor of 15 and 20 is 5. With our variables, we have a factor of a squared or 2 factors of a. A squared is 2 factors of a, and 1 factor of a, so they have 1 factor of a in common. And then we have a factor of b and 2 factors of b. Again, we have 1 factor in common. So our greatest common factor is 5ab. Writing 5ab out in front, factoring it out, dividing it out of these 2 terms, we're left with 15a squared b divided by 5ab. We're left with 3a. And then taking negative 20ab squared divided by 5ab, we're left with negative 4. The a's reduce, and 1 factor of b left over. Let's check. 5ab times 3a is 15a squared b. 5ab multiplied by negative 4b is negative 20ab squared. Okay, so how are we going to use factoring to solve equations? Well, we use the factoring method to solve equations whenever the degree is greater than 1. So whenever we have something other than 3x plus 4 equals 0, if we have x squared or x cubed, this is when we use factoring. Our steps are to get one side of the equation equal to 0, so we can use the zero product rule. Then we're going to factor the non-zero side and set each factor equal to 0 to solve. So let's do that. We already have one side equal to 0. Our greatest common factor of 4 and 8 is 4, and of x squared and x is 1 factor of x. So when we factor with 4x factored out of the binomial. 4x squared divided by x gives us x. 8x divided by 4x is 2. Now we have it in factored form. We have two factors multiplied to equal 0, so one of these two factors has to be 0. We have the choice of 4x equaling 0. Dividing by 4 gives us x equals 0. Or the factor x plus 2 equal to 0, so x is equal to -2, and we have two solutions. In number 16, we don't have one side equal to 0 yet, so let's subtract 12x from both sides. That gives us 3x squared minus 12x equal to 0. We look for our common factor, our greatest common factor. Of 3 and 12 is 3, and of x squared and x is x. One factor of x in common. So we have 3x multiplied by the quantity, and we're going to divide. 3x squared divided by 3x is x. Negative 12x divided by 3x is -4, and that equals to 0. So now we're in factored form. We're going to set each factor to 0 and solve. So 3x equals to 0. Divide both sides by 3, and x is 0. Or our other choice is x minus 4 is equal to 0. So x equals 4. And we have two solutions, x equals 0 or x equals 4. Let's do another example. We have 5x squared minus 3x equals 2x. Getting one side equal to 0 by subtracting 2x from both sides. We have 5x squared minus 5x equals 0. Our greatest common factor of our numbers is 5, and we have one factor of x in common. So we have 5x dividing 5x squared divided by 5x is x. 5x divided by 5x is 1. So we have 5x multiplied by the quantity x minus 1 equal to 0. Set each factor equal to 0. So 5x equal to 0, dividing by 5, x is 0. Or x minus 1 could be 0, so x is equal to 1. And we have two solutions. Again, getting one side of our equation equal to 0, we're going to subtract 5x from both sides. We have negative 6x squared minus 5x equals to 0. For our greatest common factor, 6 and 5 don't have a common factor other than 1, so 1. And then our variables, we have one factor of x in common. So our greatest common factor is just x. Factoring out an x, negative 6x squared divided by x is negative 6x, and negative 5x divided by x is negative 5. Setting each factor equal to 0, we have x equal to 0, or negative 6x minus 5 equal to 0. Solving negative 6x minus 5 equal to 0 by adding 5 to each side gives us negative 6x equals 5, and dividing by negative 6, x is equal to negative 5/6. So we have two solutions, x equals 0 or x equals negative 5/6. Let's look at one example of where you might see this type of equation and solution. In this case, we have what's called a vertical motion model. A vertical motion model is basically when you throw something up into the air, like a basketball, and it comes back down, or maybe you're just on the side of, up on a cliff and you just drop an object down to the ground. Okay. Our equation that we work with either one of those situations is the height, h, in feet of a projectile, that is something that is thrown into the air or dropped from a height, can be modeled by h equals negative 16t squared plus vt plus s. T is time in seconds, v is the velocity in feet per second, and s is the starting height above the ground. So here's an example that we're going to be looking at. A startled armadillo jumps straight into the air with an initial velocity of 14 feet per second. After how many seconds does it land on the ground? So v is our velocity, our initial velocity, and that's going to be 14 feet per second. S is our starting height. This armadillo jumps up from the ground, so its starting height is 0. It's on the ground. And we want to find after how many seconds does it land on the ground. So its ending height or its final height is also 0 because we end up on the ground. So here's our armadillo. It starts here, he jumps straight up in the air, and he comes right back down again. Okay, so let's put these numbers into our equation. We have h is 0 equals negative 16t squared plus v times t, v is 14, plus s, and s is also 0. So we have 0 equals negative 16t squared plus 14t. Now we want to factor and solve. So let's find our greatest common factor. Our greatest common factor of negative 16 and 14 is 2 or negative 2. You could factor out either one if you want. Let's see what happens when we use a negative 2 as our common factor. And for our variable, we have 2 factors of t and 1 factor of t. So our greatest common factor is negative 2t. Let's factor that out. We're going to take negative 16t squared divided by negative 2, which is going to leave us with positive 8t. And 14t divided by negative 2 is negative 7t. And that's equal to 0. Set each factor equal to 0. So our first factor, negative 2t equals 0, dividing by negative 2. T is 0. And then we have, this is not 7t, that's just 7. Let's do that part again. 14t divided by negative 2t is just 7. Okay, so let's set that factor equal to 0. We have 8t minus 7 is equal to 0. Add 7. 8t is equal to 7, and divide by 8. T is equal to 7/8. So we have two solutions. We have t equal to 0 seconds or t equal to 7/8 seconds. Well, we want to know after how many seconds does the armadillo land on the ground? Does he land on the ground at 0 seconds or at 7/8 seconds? At 0 seconds, this is when the armadillo first jumps. This is the armadillo's start. At 7/8 of a second, this is when the armadillo lands. So it takes 7/8 of a second to land on the ground. This is our Algebra 1 video on section 9.4, factoring to solve equations with degree greater than 1.